Hey everyone, welcome to KCD Pakistan. I am so excited to be here. I'm just, thrilled. I have a lot of thoughts. I'm very humbled, but I'm actually here to present on zero trust. And part of the reason why is because we're in this new world, this new theme of more and more security, and zero trust offers this approach. I know it seems like a bit of a gimmicky marketing term. When you actually dig under the covers of zero trust, it really comes down to allow nothing. But we can't just allow nothing to go on in our environment because we have applications that run at all times. So one thing that we start to see when it comes to microservices is how do we achieve that zero trust or the allow nothing stage or state or something along those lines. So I'm actually going to talk to you about it from the lens of using Kubernetes, service mesh, and even ambient mesh and its security capabilities, and talk a little bit about how it offers up zero trust through some of the enhancements in the world of service mesh. So let me go ahead and share my screen and we'll get started. And welcome again. So what my talk is about is what's a zero trust tunnel? And we're going to explore security and simpler operations with Istio Ambient Mesh. But before I begin, I just want to throw out a huge thank you to Sim and Bart for putting such a fantastic conference together. I am just so humbled. I'm honestly thrilled that I was asked to submit, and I was surprised, when I got accepted. So, thank you both for putting together this fabulous conference, and not only that, just putting in your own time. This is way outside of your day job, but I just want to say that it is very, very much appreciated for all that you do for the community. So thank you both. And also, thank you to all the other organizers that have been helping along with KCD Pakistan. My name is Marino Wijay. I am a platform advocate at Solo. We were formerly called developer advocates. And there's this motion or this movement around platform engineering, and everything that we do doesn't really change, even though I'm called a platform advocate. But I have to provide the perspective from the lens of operating, running, deploying a platform. Now, security falls in that realms of platform engineering, but it's not just zero trust. There's so much more to it. By the way, if you want, feel free to follow me on Twitter, or even hop along to GitHub and look up 70 Days of Service Mesh. If you really want a more structured and slower paced approach to learning service mesh. So before I get into it, I'm just going to quickly recap what the Istio Service Mesh is, because this talk is really about the Istio Service Mesh and ambient mesh security. But before we even have ambient mesh, we have this mode of operation in Istio with sidecars. And what that means is we have all of these different apps that are deployed to our, let's say, Kubernetes cluster. We have microservices that are running, and these microservices run inside of pods. Basically, we have containers running inside of pods. Now, when we turn on a service mesh or enable a service mesh, and we have traffic that is mesh bound internally, and we're having traffic go east-west, what we are actually seeing is that it's not the container itself, the application container itself, that's sending out this traffic. Well, it is, but it's not the one that's facilitating the communication. It's actually allowing something called a sidecar proxy to be able to do so. Now, the sidecar proxy, you can think of it as a very powerful, high-performing layer 7, layer 4 proxy, or router for that matter, but it also does a lot of things around policy, around observability. So it is a point of telemetry capture. So I'm running a observability system like the Honeycomb platform, for example, and I needed a way to capture some of this data about my apps. Well, I'd go to the sidecar, and the sidecar has all of that information. But the other thing too is that sidecar is facilitating all the communications for us. So we don't rely on the container to do so. If there's some sort of failure in the network, the sidecar is going to know about it and is going to be able to work around that. Now, one of the challenges with operating with the sidecar model is this idea that you actually have to be intrusive. You actually have to deploy a sidecar alongside your workload, which means it's injecting an additional container into that pod. Now, this is good, but also intrusive, and it can be problematic because as you decide, hey, I'm going to have these applications as part of the service mesh, I need to roll out this sidecar, which means I might need to re-roll out my application. through Kubernetes, which might mean a little bit of downtime. And in a lot of situations that might not even be appropriate or even allowed or even part of the policy. So here we are, Istio Ambient Mesh, a mode of sidecarless operation, meaning I still get all the features of Istio, all the capabilities. However, I don't have to deploy a sidecar anymore because I've taken that functionality and moved it. I've taken the layer 4 functionality, the functionality for MTLS, which is providing us our encryption between sidecars. I've taken that and moved it to something called a layer 4 proxy or a ztunnel. Simultaneously, I've also broken off the layer 7 functionality. So let's just say I needed to be able to deploy a layer 7 authorization policy or a layer 7 policy that just basically says I can only operate on these particular HTTP operations, but nothing else. Well, I need another proxy to be able to do that. And so we've actually created something called the waypoint proxy, or Ambient Mesh offers up this layer 7 waypoint proxy, which effectively still leverages the same principles of the sidecar. But there's a lot more details in how this all functions. So what we're going to do is we're going to actually dive a little bit deeper into how Ambient Mesh actually works and how there's still security wrapped around your workload and some other considerations and implications around that. Now, to be very clear here, when you roll out workloads in the world of Ambient Mesh, you don't deploy a sidecar. You tag the namespace for where your workloads are deployed. And now that that namespace has a particular label saying that, the data plane mode here is Ambient Mesh, well, guess what? All those workloads are now part of the mesh. But there's something interesting that goes on here for this to all work. So in Ambient Mesh, we actually do have a number of different artifacts that have been deployed here. You can imagine that this entire little cluster over to the right is comprised of 3 nodes. And whenever you go in and look and see each one of these nodes, they have something called a ztunnel. This ztunnel is actually a pod, a daemon set that's running in the cluster, and it shows up for every workload that exists in the environment. Now, what's interesting about this daemon set is that, it is a Kubernetes resource. So if for whatever reason the node goes down and there's a new node that comes online and is added into the cluster, well, Kubernetes knows to go redeploy that ztunnel pod. Now, that ztunnel pod is actually the layer 4 and MTLS sidecar. Meaning, if app A over on this little box in the left here, on the left here, needed to communicate with app, B in the middle box, well, what would happen is it would actually route its traffic to the ztunnel. The ztunnel will then tunnel it towards another ztunnel pod, and then that traffic or request will make its way to app B. Now, interestingly enough, IstioD is still the control plane mechanism to making this all work. So it'll still pass in any sort of configurations that we pass into it. Notice, though, that the waypoints are not actually deployed per daemon set. They're actually targeted towards workloads where we need to have some sort of layer 7 policy. And to look at it in a little bit more of a little bit more detail, right? What's actually going on here is I have an app here, and I have my ztunnel pod, which is supposed to be like my sidecar. And it's living on one node. And then on the right here, I have another ztunnel pod, and then I have another app. Now, if you notice here, and I'll be very brief with this, app A over to the ztunnel has this red line. This red line is simply implying that the traffic from app A to the ztunnel is unencrypted. Now, when we see the green line here from ztunnel to ztunnel pod, this is MTLS. Where's MTLS coming from? So my traffic is encrypted, or my request is encrypted only from node to node, but from app to ztunnel pod, it's unencrypted. We're actually going to dig into, why this is the case a little bit in a moment, actually. But I wanted to point out some other things too. This also applies if we decide we want some layer 7 functionality. So, hey, I might be just doing layer 4. And if you previously saw, if I'm just talking about TCP ports here or UDP ports, and I'm just applying an authentication policy of strict, then my ztunnel will have end-to-end MTLS between this ztunnel pod and that ztunnel pod as well. And then I throw in layer 7 because I have some layer 7 authorization I want to add into the mix. And as a result, I will throw in the waypoint proxy, and I will tunnel to the waypoint proxy here. And if you notice, the lines are still green, which means MTLS is still maintained. It's still there. Now, what are some of the benefits of doing something like this? Now, if I don't deploy a sidecar anymore, I don't have to worry about the race condition where my main application container comes online before the sidecar, which means now my traffic routing within the pod isn't working, which means now my workload can't communicate with workloads that do have sidecars. So now I don't have to wait for that sidecar to actually come online. Normally, you would apply this one function called the hold application timer within your application or your container manifest or your pod manifest to ensure that the application has to wait a certain period of time before it can come online so that your sidecar can set up all the traffic rerouting from an IP table standpoint. But then the other thing too is like we don't have to deploy new pods. We don't have to modify any of the deployments here. We simply just tag the namespace for ambient mesh. And now that namespace has the ambient mode data plane in action. But not only that, we don't have to worry about upgrades actually taking things offline. Upgrades actually happen out of band. So even if we lost a ztunnel because of an upgrade, well, that doesn't necessarily mean that our apps have gone offline. Now, this is also very interesting too, because of the low aspect of intrusion here. I'm not even being very intrusive at all, other than deploying a fewer set of artifacts. I'm limiting my risk and my blast radius as well. Now, the other biggest consideration here is when you deploy sidecars, you actually have to allocate additional CPU and memory to run alongside those main containers. When you remove the sidecar, you shift that over to the ztunnel, which means you're actually consuming less CPU and memory. And then you're starting to notice, hey, I'm consuming less CPU memory, I'm actually saving some money, potentially, right? It all comes down to how you've architected your applications as well. And then the other thing too is there's the underpinning of zero trust. Once we deploy these artifacts or these resources to our cluster and enable ambient mesh in the cluster, I can simply deploy an authentication policy and then in addition, an authorization policy that allows nothing. And then I can use profiling tools to see how even before I apply the allow nothing policy, I can use profiling tools to see what's actually going on, to see who's talking to who, and then I can form my posture because, hey, I kind of had a baseline go on. I can see that app A is making requests to app B and app B is making requests to app C, but oh, by the way, app B is also making requests to app D. And I can take this into account as I start to form my policies. In fact, there's probably tooling out there that'll help you generate these layer 7 authorization policies from the lens of Istio. Now, there's a few considerations here and areas that we just want to look into a little bit more. And it's really about how we get that identity for a particular application. Because here's the thing, the ztunnel pod itself on both ends is providing MTLS. But the ztunnel pod itself actually is assuming and impersonating the identity of app A. In fact, what's going on is when app A needs to communicate with the ztunnel pod, there's actually something called an Istio CNI pod that's also deployed. The traffic is basically directed towards the ztunnel to be encrypted. But it's also saying, hey, if this Istio CNI pod detects that app A is trying to communicate with app B because they're both in the mesh, well, what ends up happening is that now that's an indicator to the ztunnel to go to Istio and then capture the security account and certificate for app A and use it as its identity to form MTLS. The same happens on the destination side. Now, the other consideration here is with only layer 4 and ztunnel, that means I can only implement layer 4 policies, which means I can specify policies at the TCP layer or even the UDP layer. But one of the considerations here is if I am looking and opting for more speed, I may take this approach. If I'm using a server send first protocol or only a particular protocol out there that only responds in layer 4 anyways, then this might be the best fit using layer 4 ztunnels. Now, one thing I will say just about the process is when we need to capture the identity for a particular app, what ends up happening is the ztunnel on any particular node saying that it represents a particular workload will actually go to Istio and ask Istio to attest and sign the certificate representing A using its service token. And then Istio D will basically verify if it's allowed to represent workload A. And if it is, it'll say, looks good to me. You've got the go ahead to represent app A or workload A and use its service account and form MTLS. But that's the process in a nutshell. Istio D still is responsible for authorizing these requests from the ztunnel pod itself. And why this becomes important is because we also want to prevent any sort of instances where, let's say, the ztunnel pod itself can be compromised in any way, shape, or form, and then you have malicious actors assuming the identity of workloads. Now, quite honestly, there are some great talks about, assuming identity and even basically thinking or fooling other workloads into thinking you're the workload that you say you are. Rob Salmon and Christine Kim gave a great talk at Cloud Native Security Con just about this. Go take a look at that talk, and actually they go into some details about how to be able to create this exploit. Really cool stuff, if you ask me. Now, one thing I will point out is that the ztunnel itself will assume the identity of multiple workloads as they come in. And if there was a situation where the ztunnel pod itself was getting overtaxed because it was running out of CPU and memory, well, guess what? I mean, you could take advantage of the scaling capabilities of inside of Kubernetes and tune your daemon set to scale appropriately within a node if you needed to. Now, I will point out one other thing as well. This all still applies when you actually use the waypoint proxy. Nothing actually changes here because you will still have this ztunnel that will assume the identity of app A and then form its end of MTLS towards the waypoint proxy. But what's very interesting too is the waypoint proxy, where does it get its identity from? And it actually gets its identity from app B. So when it gets its identity from app B, it's doing the exact same process that the ztunnel would do to solicit and communicate with Istio D to authorize it to use app B's service account and SPIFFE ID. And because of this, right, now we can form MTLS this way. But within a node, the waypoint in the ztunnel will form its own MTLS tunnel to be able to facilitate that secure communications. Once the request arrives at the ztunnel in the destination node, it unencrypts that traffic or unencrypts the payload and the request, and then forwards it on to app B. Now, one more thing I will point out, a very interesting thing, is the waypoint proxy, because it's layer 7 based, actually uses the gateway API spec and effectively is using Envoy under the hood today. Now, the ztunnel, when Ambient Mesh was initially built, actually used a very slimmed down version of the Envoy proxy. Now, since the launch of Ambient Mesh, there's been a lot of work done to rewrite the ztunnel into a Rust-based proxy. And in fact, there's even some documentation on the Istio Ambient Mesh branch that talks a lot about the ztunnel proxy and even how to get it up and online in a sandbox or a lab environment. Now, why Rust? It's far more performant than using Envoy, even a slimmed down version of Envoy, which means that we will see less resource consumption for more throughput, for more request throughput. Now, there's a few other things I want to talk about with respect to security. And this really comes down to, okay, hold on a second. If you remove the sidecar from your application now your workloads are unencrypted and talking to the ztunnel. So what happens when the node gets compromised? Well, here's a consideration. Actually, before we even get to node compromise, because that's actually the next slide, we actually want to talk about the app compromise for a second. The app compromise likely would occur is if you actually, or let's say your automation pipeline, pulled down a malicious container that potentially had the opportunity to do something within your environment, to gain root access within your environment, and then start running a whole bunch of malicious commands to create a denial of service attack or something similar. Interestingly enough, this is not a problem of Ambient Mesh. This never would be. This is more of a problem of, hey, did you check your containers before you downloaded them and verify that you pulled them down from a known good source? And then also, did you scan those containers to make sure that they didn't carry any vulnerabilities that could exploit or potentially, compromise your environment? So it really comes down to other security practices as well, beyond just relying on ambient mesh. Now, this is defense in depth. The other area that we have to talk about is the surface attack area, or the surface area of attack, I should really say, for the proxy. So in the sidecar proxy, look at all the capabilities and potential points of exploitation that could occur here. Whereas when you slim down the proxy to just doing layer 4, connection handling, MTLS, telemetry collection, focusing on the TCP and UDP connectivity, well, we can lock down as much as we need to just that, the functionality of just layer 4, which means less surface area for attack, which means less opportunity for exploits, which means we know exactly what it should be doing and nothing else. We expect it to only function in this way. So we've slimmed down the proxy to be able to facilitate a much more robust and secure approach to operating, especially in ambient mesh, and then moving towards that element of allow nothing or zero trust. And then finally, this one last area I will talk about is the node compromise. It's, to be very brief here for a second, node compromises could occur for a number of reasons. Someone gained access to the physical node. If you're in a cloud environment, probably not. But then someone has your root keys, or someone has your private public key information, so now they can get into that node. Maybe someone has access and credentials to the database that has access to this. Maybe someone has access to the pipeline to be able to deploy to this. These are elements of security that exist outside of the realm of ambient mesh. It's actually not ambient mesh's responsibility to protect your infrastructure. Specifically, when you think about it, ambient mesh's role is to provide service mesh-like functionality with less resources while still performing like a service mesh, but using a sidecarless approach. If your node gets compromised, it's because you haven't been practicing security in other areas, like physical security, credential security, making sure that you're not sharing accounts or using shared service accounts. There are a lot of other considerations too, right? But it comes down to, hey, if you get root access, well, you're going to be in trouble. One recommendation is maybe consider the Talos operating system. Now, that really takes us to the end of ambient mesh and the security that it provides, and even the element of what a zero trust tunnel is. But let's quickly recap. With ambient mesh, you have a new mode of deployment, a new data plane operation, which removes the sidecars from the actual workloads. They're no longer deployed, but the functionality of the sidecar still exists in the ztunnel or zero trust tunnel. And that provides us layer 4 connectivity and even MTLS for encryption. When we need layer 7 policy, we start to deploy the waypoint proxy. And that waypoint proxy effectively allows us to provide layer 7 authorization or any sort of additional HTTP or other types of operations. Now, the interesting thing about the ztunnel is because when it was first built, it was built with Envoy, and now it's being built with Rust. And I'll share one last thing with you, right? Outside of the operational enhancements and improvements that have gone on with ambient mesh, there's a lot of work and movement towards ambient mesh becoming part of full mainstream Istio. So I'm excited about that. I'm really excited to see where this can take us. In fact, I've already started exploring edge computing with ambient mesh because of its reduced resource requirements while still providing all the benefits of Istio and the service mesh layer as well. So I just want to say, if you really want to learn more and dig deeper, I highly recommend you go download this book and read a lot about what ambient mesh is, how it functions. If you want to continue the conversation, join us on Slack, slack.solo.io. And if you want to get hands-on work, like if you really want to play with this stuff, I highly recommend you go to academy.solo.io, and you can take a variety of labs from Cilium to Istio Ambient Mesh to even Envoy to better understand how these technologies work together to provide application networking. And I want to thank you all for hanging around with me for the last 25-ish minutes or so. I've had a blast talking to you about zero trust and ztunnels and ambient mesh, and I'm looking forward to seeing you all again. Thank you, and thank you, KCD Pakistan. Take care, y'all.